So question number 2, find the scalar product of vector A, which is equals to that, and vector B, which is equals to that. So now we have to first of all understand what this question requires us to do. So the first part that the first thing that we have to ask ourselves is how do we find the scalar product? That's the first thing that we have to know. A scalar product is just the dot product. So here we are expected just to find the dot product. The dot product of vector A and B, that's the scalar product. So we have A, vector A, dot B. So A dot B, our A here is -3, -1, dot 4, -2. So now when you look at this, the way this A is represented in coordinate form, the way vector A has been represented in in coordinate form, you can also rewrite that part. So if you happen to have A, vector A, which is -3, 1. So this, we can just let this be I component, let this be the ith component and then the jth component. So this can just be written as A is equals -3i minus j, like that. Similarly, B can also be written as 4i minus 2. It's plus, but now plus multiplied by negative, it's going to give us a negative j, like that. So you can just rewrite it like that. It's one and the same. You can either write it like this or write it in coordinate form. It's still one and the same. So now if at all I write this here, -3i minus j dot 4i minus 2j. You know, to say in vectors, I multiplied by I, the answer is 1. J multiplied by j, the answer is also 1. So I multiplied by I, our answer is 1. That is in vectors. Don't look at it in terms of complex numbers. In terms of vectors, I multiplied by I, the answer is 1. And j multiplied by j, the answer is also 1. But I multiplied by j, the answer is 0. So if I tell you here dot product, you're just multiplying everything. So this multiplied by that, what are you going to get? It's like this. I'm going to have this -3i multiplied by 4i plus -3i multiplied by -2j plus -j multiplied by 4i plus -j multiplied by -2j, like that. So this is going to give us, so here, remember, this is I remember what I said, I multiplied by I, the answer is what? It's 1. So already here, I and I is going to give us a 1. So we're just going to remain with -3 times 4, which is -12. -12 plus here. So here we have I multiplied by j, which is there. So like I said earlier on, that I multiplied by j, the answer is 0. So you're going to see that this part here is not going to have any effect. This is just a 0. This part, which is also here, is also going to give us a 0 because j and I are giving us a 0. So this is also 0. So just remove it out. So we're just going to remain with the last one. -j multiplied by -j is positive. So there is just +1 multiplied by 2, which is a 2. So we have a 2 there. So this is giving us -10. So that is the answer that we have. So I showed you all this so that you don't ask me the next time if I don't just the way it is, have A dot B -3, -1 dot 4, -2. And then the day I just start multiplying, I just multiply the corresponding elements. This multiplied by that, I write the answer, say -12, plus -1 multiplied by -2, say 2, give me -10. So the next time I write that, don't ask me, but here we are multiplying, but why is it that we are just multiplying this and this, not this to that, or this to that? That's why I did all this, so that you'll be able to see the reason as to why when you just when you are multiplying the dot product, you just consider the corresponding elements, because these they'll give us zeros. So it's just this against that plus this against that which is there. Okay, now this, unless there's a question before you look at the second one. Okay, let's look at C. So for C, I'm not going to write everything that I wrote here. I'll just go direct because I've shown you everything. So we have P, vector P, we have C here. We have vector P, which is equals to √2, comma, √6. And we have Q, vector Q, which is equals to √6, comma, -2. So we have those two vectors, and they want us to find the scalar product. So we are just required to find the dot product of vector P and Q. So the dot product of vector P, Q, this is just equals to, what is my P? Is that piece there, √2, comma, √6, dot, my Q is √6, comma, -2. So here, I'll just start multiplying now. This multiplied by that. Remember what I said, this and that is giving us a 0 because I multiplied by j is 0. So it will just be this multiplied by that plus this multiplied by that part which is there. So here we have √2 multiplied by √6 plus √6. Okay, it will be just -2 multiplied by √6. So here, when you have √2 times √2, the answer here is, this is just the same as, you can just write this under one root, everything here. You just write the root of, you just get these two numbers which are here. So it is 2 times 2. So this is going to give us √4. So this is just a 2. Like that. So now that's what is going to happen. I not say this is a 2 because they're just the same. But now this is what is going to happen. So now if I tell you are going to have, if you are going to have √2 multiplied by √6, so this, rewriting this under one root will just be 2 multiplied by what? 2 multiplied by 6. Multiplied by 6. This is giving us what? 12. So now in 12, I have two factors. One of the factors is the perfect square. So I can just use that factor of 12. So when you look at it, we have 3 times 4 is a factor of 12. 6 times 2 is also a factor of 12. But now I prefer using this one because of the perfect square that I have there. 4. So now here it's just 3 times 4. So now I can chunk that again. I can rewrite that one, whereby you have √3 times 4, which is just the same as √3 times √4. So you have √3. What is √4? Is 2. So times 2, which is the same as just 2 √3. So now this part here, 2 times √6, the answer is just 2 √3. So this is 2 √3. I wrap this piece here. I move to the next part. So here, guys, we have -2 multiplied by √6. It's just, and then multiplied by positive. So it will just be -2 √6. So that √6 is, I can break this one. I can break √6 down so that I have √3. So √6, breaking this down, I can just use the factors of 6. We have 2. We have 2 and 3. So 2 times 3. And then this, you can just rewrite this, you chunk this root 2 on its own, root 3 also on its own. So root 2 times root of 3. So this is giving us what? This piece here. So I'm going, when there's root 6, I'll replace it with that. So we have 2 root 3 minus 2 root 6. I'll replace it with root 2 root 3 like that. So when you have multiplication there, it is just root 2 root of 3. So the next thing that we are going to do, we are going to factor out the common element, the common factors. So when you look at this part here, we have 2 root 3. We also have 2. We have 2 there. We also have root 3 there. So we can factor out 2 root of 3 is common. Then we are going to remain with the 1 minus, here will remain with the root 2. So therefore the dot product or the scalar product of P, Q is what we have found here. Unless there's a question. Unless there's a question before we move to question number 3. Any question, guys? Okay, silence means everything is fine. So we move to question number 3. So question number 3. Find out whether the given vectors are perpendicular to each other. Find out whether the given vectors are perpendicular to each other. So in order for us to find out if 2 vectors are perpendicular to each other, it simply means that their dot product has to give us a 0. So if I find the dot product of 2 vectors, if the 2 vectors, the dot product gives you a 0, just not to say those 2 vectors, those vectors are perpendicular to each other. So that's what we are going to do here. So question number 3, we have A, vector A, which is equals to -3, -1. We also have B, which is equals to 4, -2. Oh, I've picked a wrong question. I've picked a different question. A is equals to -5, 8. And vector B is equals to 2, 1.25. So now, in order for us to find out if the 2 vectors are perpendicular to each other, we just have to find their dot product. If the dot product gives us a 0, then we'll make a conclusion to say, indeed, the vectors are perpendicular to each other. So we have vector A here, dot vector B. So vector A is -5, 8, dot vector B is 2, 1.25. So we'll do the same. This multiplied by that. So it is -5 times 2 plus 8 times 1.25. So -5 times 2, the answer is -10 plus 8 times 1.25, the answer is 10 also. So -10 plus 10 is 0. So now that our dot product is 0, we therefore conclude that vector A and B are perpendicular. Unless there's a question. Because the question was just centered on first finding the product, the dot product. If the dot product gives you a 0, then therefore those 2 vectors are perpendicular. And indeed, in this question, the 2 vectors have given us a 0. The dot product of the 2 vectors has given us a 0. Therefore, vector A and B are perpendicular. Any question? Okay, interesting. Let's look at I'll pick the last one. I'll pick the last one on question number 3. We are still finding out if the vectors are perpendicular. We're still on question number 3 and question number 3C. Question number 3C, which is vector P, which is equals to root 2, comma 2, negative root 2, comma 2, and then we have our vector R, which is equals to negative root 3 over 2, comma, negative root 3 over 2. So even here, we'll just do the same. The procedure is just the same. So we find the dot product of P and R. So our P is root 2 over 2, negative root 2 over 2, dot, negative root 3 over 2, comma, negative root 3 over 2. So multiply the corresponding elements. So we have this multiplied by that. So this is going to be root 2 over 2 times negative root 3 over 2 plus negative root 2 over 2 multiplied by negative root 3 over 2. So root 2 multiplied by negative root 3 is just 2 multiplied by 3, which is 6. So it will be root 6, it will be negative root 6 on top over 2 times 2 is 4. We move to this part here. So negative on negative is giving us a positive. So we're going to have plus on the numerator is root 6 over 2 multiplied by 2, it's 4. So here you are seeing that here we have negative. So here we have negative root 6 over 4 plus root 6 over 4. So the answer here is 0. Therefore, vector P and R are perpendicular. So vector P and R are perpendicular. And let's place the recording here. So question number 4, find the vector U that is perpendicular to vector V, which is equals to, we are looking for U which is perpendicular to vector V, and vector V is equals to as the following coordinates 3, 4, and then the size of vector U. So the magnitude of vector U is 15. So the size of U is 15. So we have two things. The first part that we are told is a vector that you are looking for is perpendicular to vector V. So now that's the word perpendicular. So what comes into your mind? Just see the question, what are you going to conclude? So if two vectors are perpendicular to each other, it therefore implies that their dot product is 0. That's number 1. So let's find the first part. Let's let U, vector U to be equals to A, comma B, and then we are told to say the two vectors are perpendicular. U is perpendicular to V. So their dot product is giving us a 0. So the dot product is giving us a 0. That's what we are told. So it's just a matter of solving for U dot V. So our U here is A, comma B dot our V is 3, 4, and our answer here is what? 0. That's what we know about perpendicular vectors. So this multiplied by that will get a 3A plus this multiplied by that will get a 4B, and this is just 0. So we have we've established the first equation. So after we've established the first equation, for the first statement that we are given, we are done. Now let's look at the second statement that we are given, where we are told to say the size of vector u is equal to 15. So the size, so we're talking about the magnitude of vector u. So the magnitude is just the magnitude of vector u, that's the magnitude modulus. This is just equals to 15. And now the question is, what is this vector u that we're talking about? So we're just implying that modulus of u here is a comma b and equals to 15. So by definition, when you have modulus of a comma b, you not say this is equals to the root of this component, a squared plus b squared. That's what it simply means here. So therefore, this part here is just the root of a squared plus b squared equals to 15. Since that is the case, then we can just get rid of the square root by squaring on both sides. So squaring on both sides here gives us 2, and root cancels. We're going to remove a squared plus b squared is equals 15 squared is just 25. So that is our equation 2. So we have two equations, equation 1 and equation 2. So we have to solve those two equations simultaneously, because our question here is just centered on finding the values of a